Okay, so does everybody have the titles on their paper? Now let's fill it in. First thing that we're going to start with are the tangent identities. And so the tangent identities all stem from this idea of tangent, and tangent, and we should kind of know this, tangent of an angle is equal to sine over cosine. We've done sine, cosine, and tangent, right? Okay, I was kind of drawing a blank. We did sine, cosine, and tangent, and we should remember that tangent is sine over cosine. Do y'all remember that? No? Did we do a unit with it yet? Yeah. Oh, okay, this is all from, okay, then this might be new for you. Sorry, I also do private tutoring, so I can never remember what I've taught and what I haven't.
You may begin testing for today. Make sure that you do place your testing sign on your door. And for the rest of the campus, just help us out, minimize traffic in the hall as much as possible. Students, please be mindful as you move from one class to another, as we have over 100 students that are testing today for STAR. So again, teachers, one more reminder, please do look at one time and make sure that students are sitting in your classrooms this morning. And everyone, please send us to the F100 hallway if we want to come out. Do help them find their testing room. Thank you and good luck to everyone testing today. And if you're ready, you may begin your test.
Okay, so we haven't done sine, cosine, tangent yet, and usually I go through the first 2 pages in the packet first before we begin this unit, but our packets haven't come in yet. I don't want to reprint them because they're pretty big packets because it covers 2 units. So that's okay. The stuff that we're doing today, you can do it without the first 2 pages of me going through preliminary stuff. We'll go back and hopefully they come in today or tomorrow. We'll go back and do those things. But right now I'm giving you this cheat sheet and then I'm going to show you how to use it. So all of these are identities. And so we've got this tangent identity. And all I'm going to do with the tangent identity is that I'm going to rewrite it. And so tangent, I could also rewrite it. This is just algebraic manipulation. So couldn't I also take this cosine and multiply it over here? I mean, that's just algebra. So I'm just going to rewrite it. So cosine times tangent is equal to sine. That's just algebra. So like the one that you have to remember is this. Like this is the big one. Everything else is going to build off of that. And so another way that I could write this is, couldn't I also from here take tangent and divide it over here? Wouldn't that be the same? Yeah, okay, well, I'm just going to rewrite it. So I could also say that cosine of theta is equal to sine divided by tangent. And that's just algebra. So here are 3 ways to write tangent equals, sine equals, cosine equals. I'm going to do the same thing with cotangent, and cotangent is the reciprocal of tangent. So it's going to just flip this fraction. So cotangent is equal to, the way I remember it, cotangent has cosine on top. So cosine over sine. And all I'm going to do is rearrange it just the same as I did this one. So I could always take sine and multiply it over here with cotangent. Also, these are sine, cosine, and tangent. Please don't call them sin, cos, and tan. That's not what they are. Like if you see MRS as an abbreviation, what is that? MRS as an abbreviation. What is that? Okay, do we say MERS? No, we don't. So these are abbreviations, but don't call them sin, cos, and tan. That's not what they are. They're sine, cosine, and tangent. Okay, from here, I could do the same thing that I could also take cotangent and divide it over here. Cosine divided by cotangent. Okay, any questions so far? We're just making a chart. All right, the next thing that we're going to do is talk about the reciprocals. I probably should have done that first, but I didn't. We're going to talk about reciprocals. We've got sine, cosine, and tangent. And the reciprocal of sine is cosecant, and we abbreviate that as CSC. And again, sorry, we didn't go over these beforehand, but that's okay. All you need to know is this chart and how to use it. The reciprocal for cosine is secant, and we abbreviate that with SEC. And the reciprocal for tangent is cotangent, and we abbreviate that with COT. Another way that you can write these is that these things literally switch places. So cosecant is the same thing as 1 over sine. Secant is the same thing as 1 over cosine. And cotangent is the same thing as 1 over tangent. Also, writing the angle is not optional. You have to write the angle. So whether it's being denoted, it's like a variable sort of. Whether that's a theta, a TH theta, whether it's a theta, beta, gamma, W, X, Y, you have to write the angle part. You can't just write sine, cosine, or tangent. You can't just write those. Any questions on how to create these? Or how I manipulated them? All right, the next thing, and this is probably the most powerful chart. We're going to make the Pythagorean identities, and the Pythagorean identities kind of start with this, all of the, we're kind of deriving these from the Pythagorean identity, and it's going to look a lot like Pythagorean theorem, where we have a squared plus b squared equals c squared. It's very similar. This is built off of the unit circle. You guys created a unit circle. In the unit circle, the unit or the radius is a 1. And so we're going to have cosine. We're going to have cosine squared plus sine squared. And this is just my beginning. This is my Pythagorean identity. Cosine squared plus sine squared is equal to technically 1 squared, but 1 squared is 1. Also, if you notice, the square is right there in between the angle and the trig function. It has to go there. It can't go on the other side of the theta. It's not the same thing. has to go there. What we're going to do is create a chart. In this chart, and everything is built off of this one identity. And so just like we did in the other boxes, we took one thing and just kind of rewrote it. That's the same thing that we're going to do here. We're going to make one branch out one side, one branch out the other side, and then a branch straight down the middle where we're just manipulating the equation itself. So out one side, and it doesn't really matter which side. So like this is a chart that's helpful for you to be able to recreate yourself. But out one side, I'm going to divide by cosine squared theta. And then out the other side, I'm going to divide by, I didn't leave myself much room, divide by sine squared theta. And like I said, it doesn't matter if you put sine squared over here, cosine squared over there, it doesn't really matter. Out one side, you need to divide by one function. Out the other side, you need to divide by the other. So this is what will happen. And you divide each little piece. So if I divide, what's cosine divided by cosine? What's anything divided by itself? 1. Okay, so this is what we get. We get 1. What is sine? And if it's squared, that's fine. They just both have to be squared, which they are. What's sine squared divided by cosine squared? Look over here. Tangent squared. Very good. So this becomes tangent squared. Who can find 1 divided by cosine squared? What would that be? 1 divided by cosine. Where's that? What's that going to be? Yes, secant. It's right here. So 1 divided by cosine is secant. 1 divided by cosine squared is secant squared. So these charts are just taking and substituting stuff in. Like that's what we're doing all day, is taking stuff and substituting it. We're going to do the same thing on this other side. So we'll start with what's cosine divided by sine? Do you see it in the chart? What is it when cosine is on the top? Cosine divided by sine. Cotangent. And so we're going to say cotangent squared because both those values are squared. Also, here's something important to know, that the Pythagorean identities, they only work when they're squared. Only. Because 3 plus 4 is not 5. It's 3 squared plus 4 squared is equal to 5 squared. So they have to be squared. They don't work if it's cosine plus sine does not equal 1. It only works if they're squared. The other ones, it could be squared. It could be to the third. It could be any, like these can be squared, but they don't have to be. They don't have to be. Okay, so yes, cosine divided by sine is up here, cosine over sine. So we're going to say that that is cotangent squared. Theta plus sine divided by sine. What's that? What's anything divided by itself? 1 equals, what's 1 over sine? Cosecant. Oh. The next thing that we're going to do is just manipulate these equations. We're not changing them at all. We're just kind of manipulating them. And so out this side, I'm just going to rearrange it a couple different ways because I don't know how I might see it. Okay, I don't know how I might see it. That's the same reason we manipulated some of these. You don't know how you might see it. So what I'm going to do, what if we, and there's no order to doing this. It's just kind of like manipulated a couple different ways. What if we took tangent to this side and we subtracted it? So 1 is equal to secant minus tangent. And we have to make them all squared. So 1 is equal to secant squared theta minus tangent squared theta. What if we rearranged it and looking at this first one, what if we did 1 and then we bring the secant over here? So what if we put, what if we bring the 1 over so that we have tangent squared is equal to secant squared, and then we bring the 1 over here. It's just another way to write it so that we have secant squared equals, we have tangent squared equals, we have 1 equals. So I'm just going to manipulate it again. I will say that tangent squared is equal to secant squared minus 1. The last way I'm going to write it, I have it equal to tangent, I have it equal to secant, I have it equal to 1. I'm going to also have it equal to -1, just so I've got a couple varieties of how this is, and I could rewrite it a couple different ways still, but I think that this kind of is a good starting point. I could also do tangent squared minus secant squared is equal to -1. So I'm going to rewrite it like that too. Tangent squared minus secant squared is equal to -1. So I'm going to do the same thing on the other side. I already have it equal to cosecant. I'm going to rearrange it so that it's equal to cotangent, or cotangent equals something. I'm going to have it as 1 equals something and -1 equals something. So I'm going to let you guys kind of rearrange it. It's the same idea, like the order whichever one you choose to rewrite, that doesn't really matter the order you get them in, but I'm going to rearrange them on the board and we're just going to make sure we end up with the same things. Did y'all get the same things? Now, which order your lines are in, it doesn't matter. So down the middle, all I'm going to do is rewrite sine and cosine equals. So if I wanted cosine squared equals, I would have to bring the sine squared over. So cosine squared is equal to 1 minus sine squared. So this is straight down the middle. So cosine squared is equal to 1 minus sine squared, and sine squared is equal to 1 minus cosine squared. So we have this big, beautiful chart. Keep it handy. We're going to be using it all day. And the name of the game that we're playing today is just substitution. That's all we're doing. Substituting and rewriting, substituting, rewriting, simplifying. So let me show you how to use this chart. We've got all this stuff. Everything is interchangeable. And the problems that you see, these are problems directly off the homework. So 421A, this is question number 2. So I'm doing a couple of the evens with you through the homework, and then you guys can do the odds. So I'm doing a couple of the evens with you. You guys are going to do the odds. So the front side of this homework says that you need to simplify each of the following to an expression with one trig function and no fractions. So that is the goal. We're going to take these ugly looking things, simplify them down to one term with no fractions. And so here I have 2 terms. I have 2 terms and it's a fraction. Here I have 1, 2, 3 terms and it's a fraction, 3 terms and it's a fraction. So each one of these, we're going to be rewriting them, simplifying them until they get down to 1 term and it's not a fraction. So let me show you how. The first one, and this is the biggest tip that I can tell you. If you're stuck, you have to rewrite it in terms of sine and cosine. So that's like looking at this chart. Like anytime you have tangent, you can rewrite it as sine and cosine. Anytime you have cotangent, you can rewrite as sine and cosine. Okay, so the goal is to try and rewrite in terms of sine and cosine. That's the easiest way to simplify. If I have cosecant, I'm going to rewrite it as 1 over sine. If I have secant, I'm going to rewrite it as 1 over cosine. I'm going to use this chart to help me rewrite so that it's in terms of sine and cosine. Tip number 1. So here, if I have cosine, it's already cosine. I'm not going to change it. This one is cosecant. What is cosecant? It's on your chart in terms of sine or cosine. 1 over sine. So we're going to rewrite this. And anytime one of them is going to be a fraction, I write them both as a fraction. And for this one, the variable is t. It has to stay t. You can't change it. So this one becomes cosine t. And you don't have to write a parentheses if you don't want to. So this is cosine t over 1 times 1 over sine. Everybody good there? All I did was replace it. Now, what if we smushed it together? Wouldn't this become cosine t over sine t? What is that? Cotangent. So equals cotangent t. And I'm done. Did we simplify down to 1 trig function without a fraction? Be able to simplify it to 1 trig function without a fraction. Yeah, so we're done. The next one, it's question number 4. And also, please write vertically. So it's the next line, the next line, the next line, especially when you do your quiz for me and you do your exam. Do not put everything in one line like that. Like you need to do it step by step so you can see that this turned into this, that turned into this. The next one, I have secant over tangent. Biggest tip I can tell you is let's rewrite it in terms of sine and cosine. And this is going to create a fraction inside of a fraction, but who cares? I'll show you what to do with it. So we've got secant. Well, how can I rewrite secant so that it's in terms of sine or cosine? 1 over cosine, very good. So we'll have 1 over cosine theta. And what's tangent? What's tangent? Sine over cosine. All right, anytime that you have a fraction over a fraction and those denominators are the same, this is just algebra. If those denominators are the same, they cancel. And that's something common that happens. So like when you have a fraction over a fraction, if the denominators are the same, you could split the fractions and do keep, change, flip, you figure out that it's the same thing. It just takes extra steps. So we're left with 1 over sine. How can we get rid of that as a fraction? What's 1 over sine? Cosecant. So shake your head if you're kind of seeing the reason, the purpose of the chart, the purpose of the chart. Anytime you end up with squared stuff, a lot of times if you have something and has a 1 and a square, you go check the Pythagorean identities part, the bottom part of your chart. So when you look at question number 6, do you see 1 minus sine squared somewhere on your chart? What is 1 minus sine squared? Cosine squared. Oh, it's not a theta. It's a t. Over sine squared t. What's cosine over sine? Cotangent. Done. We good so far? All right, so question number 8 is just a little bit more involved, but it's the same type of stuff. We simplify, we substitute, simplify, stuff like that. So the first thing that we're going to do is what we've been doing. We're going to change everything into terms of sine and cosine. And so secant is the same thing as 1 over cosine. So we've got 1 over cosine minus cosine. So it's cosine, and I'm going to make it over 1 since the other one is a fraction. And sine is already in terms of sine. How does that help me? Well, it may not seem obvious at first, but what we're going to do is combine the top fractions. So the only way that I can subtract this one and this one is if I have a common denominator. And so to get a common denominator, I would have to multiply this by cosine t over cosine t, so that both fractions have a denominator of cosine. So I'm going to rewrite it and I'm going to combine them. So in the top, I will get 1 minus cosine times cosine is cosine squared. So 1 minus cosine squared. And when you combine fractions, if the denominators are the same, then it rewrites as 1 time. Don't multiply that. So it's cosine t. And it's still 1 fraction over sine. Everybody with me? All we did was add the top fraction. Once we did that, does anybody see 1 minus cosine squared on your chart? What is it? Sine squared. So I'm going to rewrite this. So we have sine squared over cosine, and it's not squared, all over sine. All right. Well, the same thing works for denominators. When you have a denominator, and I could make this over 1. When you have a denominator that matches, a numerator that matches a numerator, they can cancel too. But the only thing is that with this one, I have 2 here and 1 here. So I can cancel out only one of those. I can't cancel out both. So I am left with sine t over cosine t. And what is that? tangent. So that one took a lot of steps, but it's not necessarily difficult work. You're just substituting, simplifying, a little bit of algebra. When you're looking at your homework, you're going to have to do question 9. When you do question 9, I would distribute. You've got to distribute that. So you got to distribute. We good so far? Okay, I'm going to move on. And again, this is recorded, so you can always rewatch this if you're still struggling to stay up. Here's what I think that I like more about proofs. I think simplifying is harder than verifying. So verifying is a proof. And these are different than proofs that you did in geometry, because you know exactly where you're going. Okay, what's hard about simplifying is how do you know when you're done? I mean, yes, that one told us we want to get down to just one term with no fractions. But I think that what is even easier is if I tell you, okay, make the left side look like the right side. So that's what we're going to do. We're going to prove that this is equal to this. And to do that, we only work on one side. Okay, we are going to work on the left side of these, and we stop when we make the left side look like the right side. Technically, you could work the other direction, but please trust me, I have a lot more experience than you, and it is easier to make the more complicated stuff simpler than to make something simple look complicated. It's the easiest way to do it. So for question number 12, we're going to take that and we're going to rewrite it, and we'll stop when we make it look like sine alpha plus cosine alpha. So this one, we're not simplifying to just one term. We're simplifying until it tells us what we want to make it look like. So let's do it. The first thing that we're going to do is take that fraction, and this is a skill that you probably are very weak in. We're going to take a fraction and we're going to split it up. And so if I have 1 plus cotangent on the top, it is the same thing as 1 over cosecant plus cotangent over cosecant. So that's what I'm going to do, is just split that top fraction. So 1 over cosecant alpha plus cotangent alpha over cosecant alpha. And I did that. The reason I split that fraction is because I can see where I'm going. And where I'm going, I have 2 terms. I don't have 1 term. So that's why I split that fraction. The next thing I'm going to do, I'm going to rewrite things in terms of sine and cosine. What's 1 over cosecant? What's 1 over cosecant? Sine. Okay, well, that's awesome because that's the first term we need. So that turns into sine alpha. So I've got that part. I got the first part done. And then I'm going to take the second fraction and I'm going to rewrite that in terms of sine and cosine. I know that cotangent has cosine on the top. So I get cosine alpha over sine alpha. Cosecant is the same thing as 1 over sine. Here's another fraction where the denominators are the same. If the denominators are the same, bless you, they can cancel. So now I am left with sine alpha plus cosine alpha. Is that what I wanted to turn it into? Yeah, so I'm done. As soon as I can take this and box it, and it looks identical to this, then I check it off and I say that I'm done. I box them both and I check it and I say This checks, they're the same. Done and done. So now when we verify, we're turning this into what it says turn it into. Do another one. For question 14, 1 plus tangent squared, 1 plus tangent squared. Okay, I've got a 1 and I have a trig function squared. I'm going to look at my Pythagorean identities chart. So go look at that Pythagorean identities chart. What is 1 plus tangent squared? Secant squared. Okay, let's rewrite it. So we've got secant squared b over tangent squared b. Can I rewrite both of these in terms of sine and cosine? Yeah, let's do it. So secant is the same thing as 1 over cosine squared b. And then I have tangent is sine squared b divided by cosine squared b. What happens when the denominators are the same? They cancel or reduce. So I end up with 1 over sine squared. What's 1 over sine squared? Cosecant. Is that what I was trying to turn it into? Yep. Another way you can kind of think of these is like little puzzles. That's basically what we're doing. You have this, turn it into this. It's a little puzzle. So that is how you do this first assignment. This is 421A. Done. The second assignment, 421B. So get that one out. We're going to do some examples off of that one. So you'll have plenty of examples that you can look at for inspiration on like where to start to solve these yourself. Question number 4 is what we're going to start with. So what did I say is the number 1 tip? Use the chart and turn things into what? Sine and cosine. So let's do that. The first one, we've got sine squared, good. Cotangent, we can rewrite that one. We can rewrite cosecant. So let's do that. Do you guys see some stuff that can cancel once you turn things into sine and cosine? Yeah, I've got 2 signs in the denominator and 2 signs in the numerator. They can all cancel. What are you left with? So all you do is multiply straight across. I have 1 times cosine. So I have cosine on the top, that's it, over 1. Cosine divided by 1 is just cosine. Done. Any questions? Okay, let's do another one. For this one, do not be fooled. For this one, we've got 1 plus cotangent. That is not on your chart. It's not on your chart because it's not squared. So be careful. Like you can't do anything with that. So I am going to split this fraction up. So I'm going to change, if I can't do anything with this 1 plus, then I'm going to change it to 1 over cosecant. and then cotangent over cosecant. I'm going to split that fraction. So I'm going to say so I split the fraction. Once I split the fraction, I can change it into terms of sine and cosine. If you changed it into terms of sine and cosine first, it wouldn't really matter. That's fine too. But and you'll also see the more that you do practice, when you go to simplify these, your friend might simplify it in 2 steps and you might simplify in 17 steps. Like there's no right way to do it. There are faster ways, but you might go a different path and it just has a couple extra steps. So whatever you decide to do, as long as you get to the right answer, the amount of steps that you take, just understand it might be a little bit different than somebody. From here, I'm going to rewrite everything in terms of sine and cosine. 1 over cosecant, that's easy because it is sine. And then I'm going to have a fraction over a fraction. That's not an equal sign, it's a plus sign. Plus. So I'm going to get fraction over a fraction. Cotangent is cosine over sine. And remember that those angles are not optional. You have to make them. All over cosecant is 1 over sine. What happens when you have matching denominators? They cancel. So I am left with sine plus cosine. This homework didn't say you have to simplify down to 1 trig function without any fractions. So sometimes things like this could be a proof. This is a beautiful proof. If I said, make this equal to this, that could easily be a verify or a proof. But what is nice is I am giving you the answers. So you know where you're supposed to be going. So you know if you simplified it as far as you can go, and I can't do anything with that. What if it was sine squared plus cosine squared? What would it be then? 1. But they aren't. So that's as far as we can go. The next one. I am going to, let's see, I could change these in terms of sine and cosine. And does secant squared minus 1 turn into something? Check your chart. Does secant squared minus 1 turn into something? Tangent squared. Okay, so let's do some rewriting. So I've got cosine over 1. 1 over sine. And then this becomes tangent over 1. Can I rewrite tangent? What if I rewrite tangent? Then we'll all be in terms of sine and cosine and things will probably cancel. So I got cosine over 1. 1 over sine. And then this would be sine over cosine. Also, please do not do a bunch of steps in your head. Like you got to write out all the steps, especially when you're getting graded by UT or me on your open-ended questions for the quiz. Include every step. Show all the steps. It's better to show more steps than not enough steps because then they'll assume you cheated. From here, what can I do? I can cancel out some stuff. So be careful, not everything cancels, but I've got 1 cosine on top and I can take 1 cosine from the bottom. I've got 1 sine in the denominator and I can take 1 sine away from the numerator. So I'm left with sine over cosine. What is sine over cosine? Tangent. So like this step, I'm okay with you going from sine over cosine is tangent. But I would not probably be okay with you going from that step to the answer. Next question is number 19. Number 19 is one where we're going to distribute. So I'm going to show you that skill. We're going to distribute. So just like in algebra, when you got something outside, we can distribute into both pieces. So I have cotangent, tangent, plus, what would cotangent times cotangent be? Cotangent squared, very good. Cotangent squared. There is something quite lovely that happens when you multiply something times its reciprocal. And this is not specific to trig functions. It doesn't have to be trig functions. It could be regular fractions and their reciprocals. Let me show you. So just down here at the bottom, and you don't have to write this down. This is just me showing you this, what happens. So let's say we have 3/4 and we multiply by the reciprocal. The reciprocal would be 4/3. Let's pretend we multiply that. We multiply straight across. I end up with 12/12. What's 12/12? 1. So like I said, there's something quite lovely that happens anytime you end up with a function times its reciprocal. Tangent and cotangent are reciprocals. So what happens when you multiply cotangent times tangent? It just turns into 1. And you would figure that out algebraically. If you rewrote each one of them in terms of sine and cosine, you could like do that extra step and figure it out, but you don't have to if you know that property that any reciprocal, when you multiply reciprocals, the result, the product is always 1. So cotangent times tangent is 1 plus cotangent squared. 1 plus cotangent squared. Is that on my chart? Is that on me chart? What is it? Cosecant. Also, sometimes you're looking at these, aside from what, I think it was question number 8, which had several steps on the last one. All of these seem like they might be really complicated and have a lot of steps. Most of them, I would say the average is probably 3 steps. I mean, most of them don't take that long to do. Yes.
Are we gonna have to do the opposite when we expand it?
No. You do not. That's what I was saying. It's a lot harder to expand because you could almost expand it infinitely. Like there's so many different ways you can write stuff, or you could start squaring stuff and then squaring it again. And so you can take something simple like 1 and change it into sine squared plus cosine squared. And then you've got infinite possibilities. So no, we're not expanding. All we're doing is simplifying. And that's why I was saying it's easier to turn something complicated into something simple than something simple into something complicated, because when do you stop? All right, I've got 3 more that I'd like to do with you. And again, this is going to give you lots of examples. So I'm giving you 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm giving you 13 different examples. So you should have lots of examples to look at. So continuing on, question 22. What do you guys think we should do first, probably? Yeah, let's rewrite in terms of sine and cosine. There's no fractions to split up. There's no Pythagorean identity going on. So let's just start with, let's rewrite in terms of sine and cosine. So secant is 1/cosine. Cotangent has cosine on top. minus cotangent has cosine on top. Ooh, another way you could have done this one is factoring out the cotangent. I just noticed that. This one has cotangent in both pieces. You could have factored out cotangent. This way is fine too. And this is what I was saying, that there's different ways you can get to the same answer. What we're doing is fine. So cotangent is cosine over sine. And cosine over 1. Can anything cancel? Because that's usually why we turn things into terms of sine and cosine. Do you see anything that can cancel? What? Yeah, cosines can cancel over here. Can anything cancel over here? Nothing can cancel, but I could make this one fraction. And what's cosine times cosine? Cosine squared. Okay. So the cosines can cancel. And do we have like denominators? No? Yeah. So what if we put that together? So in my numerator, I'm going to get 1 minus cosine squared over sine. Is anybody seeing a vision? Nate's kind of shaking his head. You see a vision?
No.
You're just thinking? You're dancing to your music? Oh my gosh. What do you think we should do? Yes, excellent. So we've got 1 minus cosine squared, which is the same thing as sine squared over sine. What now? Yep. So one of these can cancel with one of those. And what are we left with? Sine. So we just took something overly complicated and turned it into something simple. I'm going to move down question 28. It doesn't have to be up there and it's kind of blocking. From here, I see a 1 plus sine. That's nothing. It's nothing unless I have a squared. 1 minus cosine, I can do something with that. What is that? Sine squared. So I'm going to kind of do two things. I'm going to distribute the sine in, and I'm going to change this to sine squared. So I'm going to distribute, and I'm going to change this. So I end up with sine plus sine squared all over sine squared minus 1. Don't forget the minus 1. From here, what if I split these fractions? So I get sine over sine squared plus sine squared over sine squared. I'm just going to split it into two fractions. Plus don't forget the minus 1. From here, what can we do? Yeah, anything over itself is just 1, right? So this turns into just 1, right? Anything over itself is 1. Here it looks like I've got some signs that can cancel. That can cancel. What's 1 minus 1? Okay, so that goes away. So I'm just left with This is 1 over sine. What's 1 over sine? So I'm left with 1 over sine. And that turns into cosecant. So yeah, this one is really overly looking complicated, and we kind of simplified it down. We can do it. We can do tough things. The very last one that we're going to do together today is probably the most complicated one that you have. And I wouldn't necessarily expect you to know how to do this, but I left myself a little note. I left myself a little note last year. The note that I gave myself for last year is Q number 7. So here's my idea. I'm thinking that I left myself that note because this is like quiz number 7. The quiz problem number 7 is going to be like this. That's my idea. That's why I make sure I put a note to myself to go over this. So we're going to go through it. I wouldn't expect you to know how to solve this one. You've got a lot of skills that we've learned so far, but this isn't one of them. So this skill is that I can't do anything with this right here because there's not squared. I can't do anything with it. So every other time we've had it in the numerator, and it's easier to kind of deal with in the numerator because you can split up the fraction. That doesn't work the same way when it's a denominator. You can't split it. It doesn't work like that. So to undo a binomial and a fraction, you can multiply by the conjugate. You may or may not remember what a conjugate is. It's the exact same thing with the opposite sign. So if this one is 1 minus cosine, what I'm going to do is I'm going to multiply this by 1 plus cosine over 1 plus cosine. And it's not going to make much sense until we actually do this problem. But I would make sure to do it because like I gave myself a note, I think this is a quiz question. So I'm going to multiply by 1 plus cosine and 1 plus cosine. When I do that, I'm going to have some distributing. So I can distribute the sine in for my numerator. So my numerator ends up being sine plus sine cosine. Oh, actually, I'm not going to distribute yet. Sorry. You can. It's just a little easier if you don't. Sorry. I gave myself a note. There's a faster way. So we're going to leave it in the numerator as sine times 1 plus cosine. In the denominator, this is, you may not remember how to just like when you multiply these, first of all, you have to have parentheses around this. So I'm going to do it down at the bottom because I don't have room to kind of do it all up at the top. I could do it at the top, sure. I'll do it in green so that I'm not going to rewrite this yet. So I end up with 1 times 1, which is 1. 1 times minus cosine, so negative cosine. And then 1 times cosine, so plus cosine. And then minus cosine squared. So what will always happen is that these middle terms cancel. So my denominator is 1 minus cosine squared. So I just foiled this. This is just FOIL. 1 times 1 is 1. 1 times negative cosine is negative cosine. Cosine times 1 is cosine. And cosine times negative cosine is negative cosine squared. Plus and minus cosine cancels, and I'm left with 1 minus cosine squared. I don't want to forget my second term. It is plus 1 minus cosine over sine. What's 1 minus cosine? What is this? Sine. Well, let's rewrite that. So I have sine times 1 plus cosine all over sine squared ooh, I see a couple of things. What I notice is that I have a sine over sine, so one of these can cancel. So one of these can cancel, and that's why I didn't want to distribute it yet. I didn't want to distribute it yet. It would not matter. You still could have canceled. And when I do that, do I have like denominators? Yeah, so let's put the top together. So I end up with, and I know that there's not a whole lot of room for these steps. So I end up with 1 plus cosine plus 1 minus cosine all over the same like denominator, which is sine. Looking at my numerator, what's 1 plus 1? 2. Okay, so in my numerator, I have 2. And then what is cosine minus cosine? Yeah, these cancel each other out. So I'm left with 2 over sine. Well, what's 1 over sine? Cosecant. Well, what's 2 over sine? 2 cosecant. So I end up with 2 cosecant theta. And again, I might give myself a little star on that one because I have a note that says that is like a quiz question. So at this point, you have lots of examples to help you.